A would just be 2.
Yeah.
B would stay the same. And would we work out what a third minus 4/5 is? And then it'd be just the positive of that.
Yeah, and on your calculator, you have absolute somewhere. It's shift left bracket is absolute.
Oh, yeah.
And so you can do the entire thing in the calculator.
So that would be 7/15.
That's it. That's what it works out as. Paste that. Okay, 7/15. There we go. Let's just say, what is the last one here? Part C.
Part C.
Yeah. And I'll do part B.
C is 2.
C is 2. I think B is 8. C is 2. B is 8. Grand. Do you have a graphical calculator?
Yes.
So do you want to try graphing this? Y equals the modulus of 3x minus 2.
Yeah, I've got it.
And where does the x-intercept, y-intercept?
The y-intercept would be 2.
Okay. And x, the root?
It'll be 2/3.
And so I think it's something like that.
Yeah.
2, that's 2/3. And you just have to, yeah, that's fine. There we go. That's 2/3 and that's 2. That's great.
Right, okay.
Okay, any idea how you solve this equation?
Inside of the modulus, would it just be 2x plus 1?
No. So what is the modulus of 5?
5.
What is the modulus of minus 5?
5.
And so basically the modulus of 2x minus 1 could either be equal to plus or minus 5. So if that became, if that gave us 5, then that would work. If that gave us minus 5, then it would also work. And so for these one, you can just remove the modulus, and that will be equal to either 5 or minus 5. So it'll be plus or minus whatever's on the other side.
All right.
Or itself, but there's 2 things on the left, 1 thing on the right, and so it's easier. And then you just solve those 2 separately.
Okay.
You try the one on the right, the minus 5 one. I'll try the plus 5 one.
Okay. So that I got was x equal to -2.
Okay, and the first one I got x equals 3, x equals -2. And you can see I just used it in the solver. 2x minus 1 equals 5. Whichever way you prefer. So 3 or -2, 3 or -2. And so it's just plus or minus whatever's on the other side, usually, because it's just one thing. If there's two things, like 2x minus 1 equals 3x minus 4, then there's two things on both sides, and so it'll be just as tricky. Okay, so try, or how do we do this one?
Like remove the modulus brackets. And so one of them would be the 2 minus a half x. And then the other one would be -2 plus a half x.
Well done. I'll let you do the one on the left. I'll do the one on the right.
Okay.
Absolute.
I got that to be 2.
2? Okay.
So x equals 2.
And I got the one on the right to be 1.5. And I just tried a little trick. So I actually put it in with the modulus in my calculator.
Yeah.
And so what I did was shift solve. And I tried a big number like 999, a big positive number, and that gives me 2. Then I press left, shift solve, and I tried minus 999. And so a negative number, and I get 1.2.
Right.
So if you were really stuck, you could do that. I suppose you have to realize that there are two answers if you forgot about the whole plus or minus thing. But whichever. I kind of find this way a bit quicker to do it that way, but it's all good. 2, and they said 6/5. Same thing. Okay, how do we do this?
Would it be the same? Remove the modulus.
Right.
So it's 5x minus 1. And then the symbol.
Greater than?
Greater than 3x. And on the other one would be minus 3x.
Minus 3x. And I just want to show you something. So down the bottom, 1 and 100. What sign goes in between? Greater than or less than?
Less than.
Yeah, so 1 is much less than 100, and so that's less than. What if I multiplied both of them by -1, and so it's -1 and minus 100? What sign goes in between?
That'd be greater than.
Yes, so -1 is much greater than minus 100. So when you change from positive to negative, you have to flip the sign.
Okay.
And that's just where it comes from. Okay. I'll let you do the one on the right, the minus 3x. I tried to give you the more challenging of the two.
Is it 1/8?
So my one was 0.5. Your one is probably 1/8. And so it's not equals. And so what do we have to say?
1/8 is bigger than x.
Yes, or x is less than 1/8. And this one was x is greater than 0.5. Let me think about this. No, that's okay. Let's just take a look. So x is greater than 1/2, x is less than 1/8, and that's what we have. You can solve it graphically, but basically the negative one will always flip the inequality because of this. And strangely enough, actually I couldn't put it in my modulus thing. I suppose I could, but the problem with that is I don't know which answer is which. So before it's just x equals 1/2 or x equals 1/8. Whereas with this one, I'd get 1/2 and 1/8, but I wouldn't know, is it greater than 1/2 or less than? So I just have to do the two separately, like I did without the modulus. Any questions there?
No.
Okay, so exam questions. Let's see, sketch this graph. Okay, let's try these. And I'm just kind of going ahead. Tell me if you need me to go back.
Okay.
Did I go too quick? Did you see the thing that it was?
No, I didn't see it.
Sorry. So it's actually, the reason why I skipped ahead is because I think it's too easy. I think you'll be fine. We did one very similar to it. You just put it in the exam thing. That's fine. There's just one. I want to try this one, part B. How would you do this?
Okay. So do we forget about the modulus brackets?
Right.
So then we have 5 minus 3x equals to x, and 5 minus 3x equals minus x.
Yeah, and then you would just solve those. I was just checking that because it's using f of x notation. And
yeah.
I'm very confident. Okay. I'm very confident you'll get that right. 8 on the left, I'm confident in. Let's just try. Let me just take a look at what else we've got. Okay, let's just try 8 on the right, the inequality one.
Okay. So they make that into 2x minus 6 is greater than 5 minus x. And then we have 2x minus 6 is less than minus 5 plus x.
Mm-hmm.
first answer for x is bigger than 11 over 3.
11 over 3. And yeah, that's the, yeah, x is bigger than 11 over 3.
And 1 is greater than x.
And so therefore x is less than 1.
Oh, and then 11 over 3.
Yeah, so if we usually put x on the left side.
Yeah.
So 1 is greater than x, so x is less than 1. You just flip them around and swap the sign.
Oh, yeah.
And you can see in the answer they put the x on the left. Okay, I thought you'd get it right, and you did. So the method is the same. So now it's a 5-mark question. Okay, how would you do 9b?
Would we still get rid of the modulus brackets so it becomes minus 3
Yeah.
plus x?
Yeah. Okay, minus 3 plus x.
And then is equal to the minus x plus 5 divided by 3. And then would the other equation be minus 3 plus x equals x plus 5 over 3?
X, yes. 2 x plus 5 over 3. So I'll let you do the first one. I'll do the second one.
I got minus 7 over 2.
Okay, I got plus 1. So x equals, was it minus 7 over 2? Or plus?
Yeah, I got positive 7 over 2.
Okay. I got positive 1. 1 and 7. Let's see. So we had... oh, hold on. I'm not sure if... minus 3 plus x. So these are, first of all, that one's over there. Let me get rid of this minus. Shift, solve. You must have gone wrong somewhere. Did you not put it in the calculator?
I must have typed it in wrong.
Are you able to press left? Or can you see what's on your calculator?
Yeah.
And is it
Yeah. Yeah, I didn't put it in right. So yeah, I got 7 now.
Okay, grand. Any questions there?
No.
Okay. And so I thought that would be more challenging, but it wasn't. And so they don't seem to be getting any more challenging. Do you think you'd be okay for this one?
That would be 2x plus 9 is less than 14 minus x. And the 2x plus 9 is greater than minus 14 plus x.
Yeah, I think you'll be fine for that. It's very similar to ones we did. These are just the exam questions. Okay, this is more like it. Let's do this one. How do we do this? A and B.
I'm not quite sure.
When will you get just one solution? So if you had 6 minus x modulus of that is equal to something, what would that something have to be for you to get exactly one solution? Or one repeated solution?
I would just have to just go to 1x, wouldn't it?
So that would give you two solutions, either plus x or minus x. When you're doing quadratics, when do you get one repeated root when you're doing this discriminant?
Oh, is it just 2, 1 bracket?
What do you mean, sorry?
I'm not quite sure.
So when you're doing the discriminant, well, basically, let me think. Yeah, so when you're doing the discriminant in a quadratic, it's b squared minus 4ac is equal to 0.
Yeah.
And that's because if x squared is equal to 0, then x is equal to 0 or x is equal to minus 0, and 0 and minus 0 are the same number.
Okay.
And so this is the same idea. So it's when this is equal to 0.
Okay.
And so what is the value of x for this?
6.
And so I believe that's probably the answer for part B. X equals 6. And so if x is equal to 6, what is k?
Would we still do the the 6 minus x equals a half x plus k?
Yeah, you could do that.
And then get it to equal to 0?
Yep.
Does k have to equal minus 3?
I think so. A half x plus k equals 0. So k equals minus 3 and x equals 6. So x is 6 and k is minus 3. Yes. Yeah, so basically you get one solution and only one solution when the modulus is equal to 0. Any questions about
Okay.
Any questions about that?
No, I don't think so.
And what if I said the modulus of x is equal to minus 1?
X would be... is it just minus 1?
And so if you put in modulus of x is minus 1 into your calculator, would you get minus 1?
Wait, to equal to minus 1?
And so is there any number that when you put it in like the modulus, you'll get minus 1?
No, because the modulus always makes it positive.
Correct. So the modulus of x is always greater than or equal to 0. And so this one is like no solutions. And so it's a bit like the discriminant, where if it's negative, there's no real roots. If it's equal to 0, there's one repeated root. And if it's bigger than 0, it's 2 real roots.
Okay.
So it's very, very similar idea. So modulus function, x1/2 or tick. How do you feel about it?
That's a check.
That's great. Okay, functions and mapping. Okay, this one. Is it a 1-to-1, many-to-1, or one-to-many? Do you already know this?
A is one-to-many.
Mm-hmm.
Is B one-to-one?
Mm-hmm.
I'm not quite sure about C.
I think C is 1-to-1. So that would be slightly different. That would be, you see, the infinity thing is a bit weird. I think it's 1-to-1. And then how about the last one?
That's many-to-one.
Let's see. Many-to-1. So let's see. So A was 1-to-many. B is 1-to-1. So C is 1-to-1 as well. Yeah, that's what I thought. So 1-to-1, because for every x there's only one out. And then the last one is many-to-1. Oops. And so you have to say whether it's a function or not a function.
What makes it a function?
So it's a function if it's either if it starts with a 1. So 1-to-1 or 1-to-many is a function, but many-to-1 is not a function because it won't have an inverse function.
Oh, okay. So A to C would all be functions then?
Yes. And then that one's not a function. And hopefully I'm remembering that correctly. Let's see. Oh, it's the other way around, is it? Wait, hold on. Every element. Oh, where did I go wrong here? Functions. A mapping is a function if every input has a distinct output. So I think. Sorry, if it's the second one is 1. It's the second thing is 1, sorry.
Okay, so it has just one answer.
Yes. And so
that would be, is it B, C, and D?
So B function. Is it? So that's not a function. Function. That's not a function. Why is this not a function? Oh, okay. So there's one special thing in C, and that's because x equals 0 is infinity. And so it doesn't map onto a specific y. So x equals 0 does not get mapped to a value of y. Yeah, so it was almost a function, but it's kind of a special one. It has a discontinuity. It has an asymptote.
Okay.
Okay, let's try this. Do you already know domain and range?
The domain is the x functions, or the x input, and the range is the y.
And so for each of these you have to find the range.
I think you can find the inverse function and the domain of the inverse is the range.
True, but we have to find the range of the function, not the inverse function. So that wouldn't actually, we would still then have to use the values of x that they've given us to get it.
Oh, would we just have to input all the x values that they've given us into the function?
Yeah, that would work.
And the range between them?
Yeah.
Um, so the range is between y equals 1 and y equals 10.
Yes, and I believe the way you would express that would be y is between 1 and 10.
Okay.
So 1 is less than or equal to y is less than or equal to 10. Let me just check that. Range of f of x is 1, 4, 7, and 10. Okay, so it's discrete. Okay, so no, they want it like that. So y equals, and then curly brackets, 1, 4, 7, 10. So actually 1.5 isn't in the... yeah, so part C has it between that and that. Okay. Okay, how about part B?
Would we do it for all the x values between -5 and 5?
Yeah.
Is it just 1, 4, 9, 16, and 25? Because all the minus x's will turn positive.
Okay, and so say them again, sorry.
1, 4, 9, 16, and 25.
Okay, so I'll just put this as 1, and then this one as 25, and just see. So I use my graphical calculator, and so this one is when x is between -5 and 5. And so how would you write the range?
Is it using the less than and equal to signs?
And what would you say for the range?
So it'll be 1 is less than or equal to y which is less than or equal to 25.
And why 1?
Because 1 squared is 1.
Is there any other number in the middle there that when you square it you get a number smaller than 1? Or maybe,
No.
or maybe what's the lowest point on my graph?
It'll be just the x-axis.
And what's the value of y on the x-axis?
It'll be 0.
Yes, don't forget that 0 squared is 0. 0 is the smallest square number.
Okay.
And what can be very helpful is to use your graphical calculator. So for the first one, you can see how I just used a table of values, 1, 4, 7, and 10. The reason why graphical is good is because this is continuous. So this includes like 4.5, 3.5, 1.25, all of them, you know, minus 1.1.
Okay.
Yeah. So question C, how about that?
So would the lowest one be a third?
Okay.
And that'll be just less than y.
So I think it'd be less than or equal to, because you get a third when you put in 3. And it's less than or equal to 3. So 3 is included.
Okay. And then it will be just 1 is greater than y.
So I think, but on the other side it would be like basically less than infinity or something like that, dividing by 0. So I think it's just y is greater than or equal to a third. Is that right?
Okay.
Now I'd have to draw the graph for that. So before I tell you the wrong thing. So that's 1 over x. And we're doing this between 0 and 3. Oh, to see what it looks like. So I've got this one here. So between 0 and 3. So this is a third, probably about here. And then the other one is infinity on y. Yeah, so y is greater than or equal to a third. I think that's what it is.
Okay.
Let's take a look. Yes, h of x is greater than or equal to a third. And then the other one was, it's between 0 and 25. And for each of these, is it 1 to 1 or many to 1?
Would the first one be 1 to 1?
I believe so, yeah. It's a straight line.
B would be many to 1.
Yeah, 5 squared is the same as minus 5 squared.
And would be C 1 to 1.
Yes, 1 to 1. And I believe the reason why it's a function is because it's not equal to 0. I think if it was or equal to 0, then it wouldn't be a function, because then x would have no y to map onto. So that's 1 to 1, many to 1, and 1 to 1. Great. Any questions about those?
No.
Okay, so the graphical calculator helps a lot for this stuff. Okay, how do we do this? Do you know?
Would we just graph?
Yep.
Both of them.
Yep.
How do you do the 1 is greater than x for the functions?
So I would start with the 5 minus 2x and just do like 1 or smaller, something like that.
Yeah.
So let me see. Forget how to. All right, I'll just have to delete that. Let's see. Let's delete these. Yeah, and delete that. Yes. So let's start by putting in 5 minus 2x. Well, you can kind of do it by kind of common sense, but we'll see. So if you do 5 minus 2x, and let's go up. Let's just draw it. See what it looks like. So that's what it looks like when x is less than 1. So we can do press shift and we get some options. I just forget. I saw it a second ago. Yeah. Tools, modify, draw. Oh no, sorry. Yeah, we draw that. Shift. Sketch. F4. No. No. Draw that. Shift. View window. Yes. Shift V window. And x minimum would be 1. And then the x max,
Okay.
we can just say like 999 or something like that. And we can use that. So exit, execute. Oh no, that looks weird. I can press left. No, it's probably best. Shift, zoom, auto. Okay. I'll try zoom. No. Shift, view window. I'll try go back to that. So the x minimum minus 999, and then x maximum is 1. When x is 1, that's 5. Oh, that's just, nah, that's more complicated. How would you do it without a graphical calculator?
We would just look at the values that are all less than 1.
Yeah. And so what would you get when you put in x is 1?
You would get 3 for the first function.
Yeah. And then what would you get for all the values after that? So how would you basically draw that line, and x has to be less than 1, and so y has to be less than 3. So that's basically the point where you would stop.
Yeah. So the range for that one would be for the range for the 5 minus 2x, would it be y has to be bigger than 5?
So I think for this one, so if you were to just sketch this graph, 5 minus 2x, if you were to just normally sketch that graph, it would look something like that.
Yeah.
We said that x can't be bigger than or equal to 1. So when x is 1, y is 3. So let's say that's there. And so we would just cut it off there. And so that is when x is 1 and y is 3. And then you would continue the rest of the graph. So what do you get when x is 1 for the second graph?
4.
And so when x is 1, this one is 4. So that's going to be up here. And then you would just draw that graph x squared plus 3. And that would just be a normal like x squared graph, so it looks something like that.
Yeah.
And let's see. You see how this one is greater than or equal to x, the second one?
Yeah.
That's a filled circle. So you probably remember from GCSE when you have something like x is less than or equal to 3, you have your number line, and that one's 3, and you do the filled circle, and it points this way. If it's unfilled, x is greater than 1, then let's say that's 1, and it's like that. It's unfilled, and that's why they're like that. So it comes from that.
Okay.
And that's what it looks like. That's it there, that graph. So that one's a straight line and it just stops at that point. And then this one is the curved line and it stops at that point.
Okay.
State the range of the f of x. What is the range of the f of x?
So would y have to be bigger than 3?
Yes. So for the first part, the f of x is greater than 3. For the second part, the f of x or y is bigger than or equal to 4. And so overall it's greater than 3. And then how about part B? You have to solve that.
I'm not quite sure.
You just sub it into both of them and solve each of them separately.
Okay. So that would be 5 minus 2 times 19 for the first one.
So 5 minus 2 is equal to 19.
Is that minus 7?
Yeah. And what's next?
And then the x squared plus 3 equals to 19.
Yeah.
And then x equals to 4.
And is it x equals 4 or x equals minus 4?
It could be both.
And if we check the graph or the domain for that second one,
X has got to be bigger than 1, so the only answer would be positive 4.
yes. And so x is equal to positive 4. That's it. So it just gave us one thing. So we always tend to go for the positive, but it actually might have been going the other way, and so it could have been just a negative one. So we just have to watch out for that. Let's see. So x equals minus 7. The solutions are, so that was plus or minus 4, but we had to choose just the plus one. So x equals 4 and x equals minus 7. Yeah, so this is a piecewise defined function, and so it's in pieces, and you just have to do the two separately.
Okay.
Any questions about
that? No.
And I think these are the tricky ones. They're graphical. Let's see. Just want to see this one. Sketch the graph with this equation. So we did those already. So that should be a function has this domain. So let's try question 7 here.
So is A part of the domain?
The domain, yes. So basically they're saying, well, let's just solve this. X squared minus 5x plus 8. Or no, hang on. Let's sketch it. X squared plus 5 minus 5x plus 8.
So it would have a y-intercept of 8.
Okay. So it's y-intercept of 8. And what about its minimum?
I don't know.
So do you have it on your graphical calculator?
Yeah.
So if you do shift F5 for graphical solve.
Yeah.
And choose minimum.
So that's x equals 2.5 and y equals 1.75.
So it's 2.5 and 1.75. And so, what do you know about it if it is a function, a one-to-one function?
Whatever you input, it can only have one output.
Yeah, and so with this previous one, we have to kind of, we kind of cut it off halfway for some of these?
Yeah.
Where would we cut this off so that it only has one output for one input?
Would it be when x equals 2.5?
I believe so, because after that it's going to repeat. And so I believe x is greater than or equal to 2.5, and so a is 2.5. 5 over 2, 2.5, that's it. And so it's often the minimum, the local minimum for some of them.
Okay.
Okay. Oh, these ain't easy. Okay, let's try 8 on the right.
So when we can put both of them into the graphical calculator.
Yeah. Or
but for the first one.
So I found the graphical calculator a bit confusing, so maybe it'd be easier to do it without it, just using normal stuff.
Okay. So the line 2 plus x is just y equals x, but the y-intercept is 2.
Well, what is it when x is 4?
It's 6.
Okay, and so it would be, so how would you sketch just 2 plus x and y equals 2 plus x in general? What would it look like?
It's a straight line.
Yeah. and it's usually something like that. But we are saying x is less than or equal to 4. So when x is 4, y was 6. And so what do we do with that point?
We get rid of anything that's past x is 4.
Well done. And what do we put at that point?
A coloured in circle.
And yes, well done. Okay, and for the next part?
Could you put in... It's the upside down parabola. Because it's a minus x squared. It's y-intercepts minus 17.
Yeah.
Would we work out what the maximum of the equation is?
Yeah, I think it would be helpful to actually to sketch it.
So that point is 5 for x and y equals 8.
So what do you mean 5 for x? When x is 5, y is 8, is it?
Yeah.
Okay, what
about for the maximum of the parabola.
Ah, okay. So 5 and 8. So something like that. Where does it cross the x-axis? And you can do shift solve and shift graphical solve, F5 and choose root.
Yeah. Is it... I'm not quite sure.
Shift F5 graphical solve root, and it says it is when x is 2.17. So that there. Oh, hang on, that's on one side, is it? So I press right to go to the next one. X is 7.8. And but what about when x is 4? Because it starts at x is greater than 4.
Would we just put in 4 for x?
Yeah.
I've got 7.
7. And so what do we put at 4, 7?
That would be a open circle.
Well done. And so that's open circle. Then we've shown the maximum, and we've shown the root to the right, which is 7.8. Is this something different? Let me just check. That's 4.1. I think I have... Oh, sorry, I'm just looking at that one. I don't have the answer for it. Ah, well. I only have the one here. Yeah, but I'm happy with that.
Okay.
So we did the hardest stuff anyway. How was that for you?
That was good.
Okay, so we didn't get to composite and inverse functions. We got a lot. I think these graphical ones are the hardest ones. So anything in particular you want to do next time? I feel like we can do the second half of functions, or we can do something totally different.
I think we might do the second half of functions.
Okay, finish this. Any questions for me in general?
No.
All right, well done, Eva. You did great. I look forward to chatting again next week.
Thank you.
Have a good week. Goodbye.
Bye.